Alright, year 8. So I'm going to be using this video to go through the solutions to the half-yearly practice questions that I posted up earlier. So just have a copy ready loaded on your screen or print it out, and it'll just make it easier to follow through with what I'm doing. So I do apologize if I sound a little bit tired. It is 2:30 AM. Anyway, let's get to it. So let's have a look. Alright, so question 1, does a equals 5 satisfy the equation 7 minus a equals 1? Okay, so when the question says if a value satisfies an equation, it pretty much means if I was to put that value, a equals 5, into here, the number sentence would make sense. Yeah, if the number sentence or the equation makes sense, then that answer satisfies the equation. So I would just write substitute a equals 5, and then I'll write 7 minus 5. Okay, and I can identify, I can just write left hand side to say that I'm working with the left hand side of the equation. Let's write that in the middle. Yeah, so left hand side is 7 minus 5, which equals to 2. Yeah, so 2 does not equal to 1. You can write left hand side does not equal right hand side. Yeah, so therefore a equals 5 does not satisfy. Equation. Alright. I mean, there's more ways to do this question. You could just simply have written, 7 minus 5 equals to 1. And then 2 equals to 1. But 2 doesn't really equal to 1. Yeah, so we use the equal sign. And you can just jump to your concluding statement. But this way of writing, it comes useful in the later years, because you will have to do a lot of proving with the left hand side and right hand side of an equation. So just wanted to expose you guys to it early. Alright, question 2. So that was question 1. Question 2. Grab another pen. Okay. So it says, explain why x equals 8 is not a correct answer to the equation, given that y is 4. So kind of similar to the question before. We're gonna say that we're gonna solve. There's a few ways to do this. You can. One way is just solving for x, and we can do that now. X plus 7. Yeah, so they give us y is 4. So let's just do x plus 7 over 3. Plus, what was y? 4 equals to 10. Okay, and now, once again, peel the onion if you'd like. So 4 is our outer layer. So we get rid of that first, so minus 4. So x plus 7 over 3 equals to 6. X plus 7 divided by 3, I'm going to times by 3 to get rid of that. Times 3 here. Okay, this cancels out that. And then minus 7. Both sides. X equals 11. So from this equation, given that y is 4, the answer is x equals 11. So you could write something like x equals 8 is not the correct solution because x equals 11 is the solution to the equation. So something along the lines of that. Doesn't have to be exactly the same as my words. So that's what I wrote. Okay, so that's one way of doing it. So another way, just gonna let go of that. We could have also done, we could have just substituted x equals 8 and y equals 4 in the beginning. Could have done that way too. So this is another way, same question. So I'm going to substitute x equals 8 and y equals 4. And we're going to see if the number sentence makes sense. So 8 plus 7 over 3 plus y is 4 equals 10. Yeah, we're going to check if the left hand side equals the right hand side. So let's just work and simplify the left hand side. Left hand side equals 8 plus 7 is 15 over 3 plus 4. 15 divided by 3, we know that is 5, which is 9. Yeah. But 9 does not equal 10. Right, so left hand side does not equal right hand side. Explain why x equals 8 is not the correct answer. Yeah, so that really says why x equals 8, because when you put x equals 8 into the equation, the number sentence doesn't make sense. The left hand side doesn't equal the right hand side, so therefore x equals 8 is not the correct answer. So that's just another way to do that question. Okay, so question 3. Question 3. Calculate the perimeter of this shape. So we did go through this in class, but I'm happy to go through it again. So perimeter is when, I remember I drew a person here walking around the entire shape. That's what perimeter means. And I spoke about probably this part here, the curved part, the circumference being the hardest part to find out, because you know the straight edges here, you can obviously just do 6 plus 6 plus 6, but it's just a curved surface. So we can label it. We'll do curved or circumference, or yeah, alright, circumference or half circumference. Yeah, circumference of this circle is half a circle, so instead of our normal formula of 2 pi r, that's for a full circle, we're just going to times that by a half, because we're dealing with half a circle. Okay, and then I work it out. So our radius from here to here is 3 centimeters. Okay, so it's half the length of the full 6, so I can just write half times 2 pi. The radius is 3. Okay, and then half times 2 pi times 3. You can just chuck that in your calculator. Okay, so we'll put that in our calculator. Half times 2 pi times 3 is 9.42. And I didn't specify how many units to round off this question, so let's just assume it's 2 decimal places. It's 9.42 centimeters. So then we can do perimeter now. So perimeter will be total of everything. Sorry, camera's a bit shaky. Perimeter is, so 6 plus 6 6 plus 6 plus 6 plus the circumference which we just found, 9.42, and add that in your calculator. So I've got the exact value here already. You can just add 18 to it. And don't forget your units, very important. Centimeters. Alright, next question. So, question 4. Uh, 12abc cubed divided by 24 a squared c squared. Okay, so just a heads up, this cube, this power of 3 only belongs to the c, because I haven't put a bracket around any other term, so you can assume this belongs to that. Now we're just going to simplify, so we're just going to cancel out like terms. So 12 and 24, they both can be divided by 12. So choose the highest common factor that both of these, the highest common factor between both of these numbers, and that's 12 in this case. So 12 divided by 12 is 1. 24 divided by 12 is 2. Then I see a at the top in the numerator and a in the denominator, so I can cross out 1a from the top, and I'll cross out 1a from the bottom. So that means I have to cross out the power. So now there's only 1a at the bottom. B's, there's only 1b, so it can't cancel anything there. And c's, there's 3 c's at the top and 2 c's at the bottom. I cancel out 2 c's from the bottom, and I cancel out 2 from the top. So I cross out that power of 3. So now there's only 1 c left. So then I just rewrite, I'll just write it to the right, what I have left. So I have 1 times bc, so just bc, over 2 times a. And just double check that I can't, if I can simplify that, and I can't. It's in simplest form, so I've done all I could do. Alright, question 5. Find the shaded area. Shaded area. So if you had the square here, take away the area of the circle, you'd get okay, so it's a bit wonky. You get the shaded area, which I didn't draw very well. Okay, so that means we need the area of the square minus the area of the circle to get that. So I'll just label this A1 and this can be A2. So when I write a number at the bottom, it's called subscripting, and I use that to differentiate between different types of areas or whatever thing I'm doing that I'm going to be repeating the letter, so just to distinguish between the two. So A1, area of the square, is, this is just the way I like to do it, so if you guys have another way that you're more comfortable with, you're more welcome to do it. Area of a square is just side times side. And you can assume it's a square because the length from here to here will be 24. But if the diameter of the circle is 24, then this is also the diameter up here, so this will also be 24 up there. Okay, so I'll just write it here. Jeez, that was... Okay, so A1 is just 24 times 24, which is 576. I'll leave my units to the end. A2 is a circle, so area of a circle, you need to remember that's pi r squared. Pi times the radius, so the radius of the circle, whichever way you want to start, so let's say the radius is here, that's half the length of 24. So 12 times, pi times 12 squared, which is, shift pi, times 12 squared, 452.39. So once again, I did not specify how many decimal places, so I'm just going to go with 2. So therefore, A equals A1 square, take the area of the square, take away the area of the circle. So area of the square is 576. Take away 452.39. So I've got that answer already here. My exact answer, just the 576 minus the answer, yeah, because I'm using the whole exact value. Doesn't matter if you retype it in. It's just a good habit to use the exact value that you've obtained from the previous part. And my units is kilometers squared. Okay, so question 6. Solve the following quadratic equation. So minus 4x squared equals minus 64. So when a question says solve, we can always use the peeling the onion method, or whatever method you have that works better. Okay, so the core of our onion is the letter we're trying to solve. The next thing that's connected to this x, well, obviously both of these are connected, but the next thing that's directly connected to it is the square. And then the last thing is the minus 4. Okay, so I'm going to get rid of the minus 4 first. So minus 4 is connected to this x squared by multiplication. So to get rid of it, I need to divide by minus 4. Because I'm doing that, I need to do it to the other side as well. So minus 4 cancels out minus 4. X squared is now equal to, if you put that in your calculator, it will be 16. And we spoke about how to get to do the opposite operation of a square. We need a square root. So I'm going to square root both sides. And the square root cancels the square. X then equals plus or minus 4. And remember, when you square root a number, we spoke about it, that there will be a positive and a negative version of that answer. And I did speak about my experience of losing a mark in an exam when I forgot the negative answer. So you must remember that negative 4 squared, if you put that in your calculator, you get 16. And 4 squared also gives you 16. Hence the two answers, the minus and the positive. So this is the answer here, okay? So this is just trying to show you that there's two answers. Okay, so it's question 7. Where are we? Here we are. So let's see if you can see that. So you should have it on your system. I'll just write it here. So 7xyz over 15z divided by 28y squared over 5xz cubed. Okay, so fractions, we need to remember when we divide fractions, we change this division sign to a multiplication and we flip over the second fraction. So 7xyz over 15z times 5xz cubed. So I flipped it. Okay, so now I've got times. So now I can just start crossing things out. It's gonna be easy, and I'll use a red pen to cross out just so you guys can see it clearer. Where am I? Okay, Z. So I've got a Z up here and a Z down here. So I could have crossed that out from the beginning, but I like to leave my cancelling out stage when I'm doing everything. So I'll cross out a Z here, I'll cross out a Z there. What else can I do? 5 and 15, they can both be divided by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. 7 and 28, I can divide them both by 7. 7 divided by 7 is 1. 28 divided by 7 is 4. What else can I do? So I think I still have the x there, but I can't cross out. There's no x's at the bottom. So you can cross something out that's diagonally down from the numerator, as long as it's something from the numerator and denominator. It doesn't matter where it is in terms of the positioning of the fraction. I can cross out a y from the top and a 1y from the bottom. I think that'll be it. So we're left with 1x Pretty sure that x is still there because we didn't cross it out. Times another x up here times z cubed. So we have x squared z cubed over. We have 3 times 4 times y. So that'll give me 12y. And you can just double check your fraction that nothing can be simplified. As in, it can't be simplified any further. And I don't think it has. I don't think it can be simplified any further. So question 8. Let's see if I have enough space for this. Question 8. Alright. Okay. Okay, so question 8. It says solve the equation 6x over 5 minus 2x plus 3 over 2. So it's an equation, but it just has fractions in it, so it makes it a little bit more difficult. So first thing, when we have to add or subtract fractions, we should know and remember that we have to have a common denominator. Okay, so looking at that 5 and 2, the common denominator will be 10. So to make this 10, I have to times the bottom by 2 and times the top by 2. To make this a 10, I have to times that 5 and times the top by 5. So now I'm going to times the top. So I'm going to write it now. So I have 6x times 2 is 12. And by the way, when I'm changing my fractions, I don't need to change this 4. It's not part of it because I'm just making a common denominator for my fractions for now. Minus. So I'm going to write this minus. I'm going to write it up. Yeah, so that minus, remember we spoke about it going anywhere it wants. I'm going to bring it up. So, got to be very careful here. This 5 multiplies the whole numerator. So I have to use a bracket to indicate that the 5 is multiplying to everything. So you know, yeah, and then that's all over 10. Which equals 4. So technically they were both two separate fractions before, but when I have a common denominator of 10 in the next step, you can combine the fraction together because they have the same denominator. So I did skip a step there. Next, I'm just going to get rid of my brackets, so I'm going to expand this minus 5. It's going to multiply into the 2x and into the 3. So this minus sign here is a common mistake that we forget to bring with us. Okay, so when we're multiplying this by the 5, it's technically multiplying by negative 5. Okay, so equals here, equals 12x minus 10x, because minus 5 times 2x, minus 5 times 3 is negative 15. Equals 4. Okay, 12x minus 10x, sorry, can't say that. Uh, 12x minus 10x is 2x minus 15 over 10 equals 4. Now I'm just going to solve it like a normal fraction equation. Multiply 10 to both sides. So 2x equals 40. Keep going from there. Minus 5 is 40, and then plus 5 to both sides to get rid of that minus 5. 2x equals 45. X equals 45 on 2. Okay, and that is it, is an improper fraction. Happy to leave it like that. And the last step you can do, if you're worried, you're not sure if you've gotten this answer right, you can sub it back into the equation. Sub x back into here and here, and put in your calculator to see if this left hand side would make 4. Okay, so that's the substitution step that you can use to check. Alright, question 9. So look at the question. So Alison and Flynn's combined age is 40. Given that Flynn is 4 years older than Alison, write an equation and use it to find Alison's age. Alison and Flynn's combined age. Okay, so you can write something like age of Alison is X. If you want, you can write something like that. Age of Flynn equals Y. So we know the combined age is 40, so that means X plus Y is 40. Given that Flynn is 4 years older than Alison, write an equation and use it to find Alison's age. So Flynn is 4 years older than Alison. Okay, so here's the tricky part. We're gonna have to write this as another equation using X and Y. Okay, so if Flynn, let's say Flynn is 36. Hypothetically, then Alison has to be 36 minus 4 because she is 4 years younger. Yeah, Alison is 4 years younger than Flynn, or Flynn is 4 years older than Alison. Depends how you look at it. Okay. The reason I do this is because I do get confused when I assign my variables. So Flynn was Y. Okay. Y equals X. Okay, so my brain's having a bit of an issue here. I'm just trying to think. If Flynn is 4 years older, where's Flynn? Okay. Flynn is 4 years older. Yeah, I think that's right. Y equals X minus 4. Okay. My brain is not functioning at the moment, so I think that's right. So X plus, instead of using Y now, Flynn, we know Flynn, the Y here, Flynn's age, we can, instead of writing Y, we can write X minus 4, which is this value here. Okay, so I've just substituted this Y with that Y. X plus X minus 4 is, so when I add two of the ages together, I get 40. 2x minus 4 equals 40. We plus 4 to both sides. 2x equals 44. X equals 22. Okay, so if x is 22, 22 plus something is 40. So if one person was 22, the other person has to be 18 because the question says their combined age is 40. So 22 plus y is 40. Y has to be 18 if you just solve it normally. Now, because I'm actually not sure if I even did that right, is in this part here, I'm going to check. So X was Alison. So this is Alison. That means this has to be Flynn. Let's see if that makes sense now. Is Flynn 4 years older than Alison? No, she's not. That means I did it wrong, see? Because Flynn is 18, Alison is 22. Okay, so that can't be right because it says Flynn is 4 years older than Alison. So I've made a boo-boo. That's fine because that happens. I'm gonna have to do that again. Maybe I should edit that part out. Alison Flynn's combined age is 40. Alright, here we go again. Here we go. x plus y is 40. Given that Flynn is 4 years older than Allison. So which one was Flynn? I don't even remember. Age of Allison is x. Age of Flynn is y. Okay, Allison, and that's Flynn. Flynn is 4 years older than Allison. So if this is Allison here and Flynn is here, instead of y, I can just write x plus Allison plus 4. Okay. So Flynn's age, I could write Flynn's age as x plus 4 because she's what Allison is, which is x, but 4 more than that. Okay, so all I'm doing is instead of writing y, I'm writing x plus 4 for her Flynn's age. And when I add them both, I still get 40, okay? So now, x plus x is 2x, plus 4 equals 40. Minus 4 to both sides. 2x equals 36, x equals 18. Okay, then if x is 18, that means 18 plus y is 40, the sum of both of their ages. Y must equal 22. Okay, now let's double check that again. So if this is Allison and this is Flynn, so Allison is 18, Flynn is 4 years older than Allison. That's 22, and that does make sense because 22 is 4 more than 18. So I do apologize that we took a while to get that. And I did tell you guys that I still struggle, even to this day, with the literacy questions. As soon as the question gets wordy, I get confused, which was evident just then. Okay, so the last part is question 10. So what is the distance of AB in this cube? Okay, so AB. Ooh, alright. Bit tricky. See if I have a ruler. Alright, kind of have a ruler. Let's use my protractor. AB is here. Okay, so AB, that's the distance of AB. That's what we gotta find. Here to here. So what you need to be able to do in an exam is kind of, I mean, you're gonna have to draw stuff on your diagram. So let's say you've drawn AB and you're not sure how to work it out. But then some of you might start seeing that you can actually make a triangle from this. Okay, so I want to use this side here. Then I'm gonna make there. I am making a dotted because it's inside the cube. So that's a square I have in there. And this will be a right angle triangle here. So okay, that kind of helps us, because if I can find this length here, this cube is it's a cube, it says, so this side has to be 1 meter, and so does this side here. So I've got 1 meter here already, and it's a right angle triangle. Okay, a cut that I've made directly through the cube. So we've already learned something called Pythagoras, which deals with right angle triangles, but I still need more information to find AB. I need the length here. We can call that C. We need to find AC. Once we have AC, we can use AC and this one to get AB. So AC, there's another triangle actually with AC, so we're going to have a look at this. I'm going to use a highlighter, this will be easier. So there's a triangle here. Yeah. AC. So you can see that there. Okay, so that's pretty much the base of the cube. And there's another right angle here. So sorry, I didn't mark that really well. Cool, so now I've got a right angle triangle, and I know this is 1, and I know that's also 1 here. So I can use that to help me find AC. using Pythagoras. So shift this over. Jeez, it's a bit cool. So AC, so I'm gonna write what's the formula for Pythagoras? So a squared plus b squared equals c squared. Yeah, so the sum of the two shorter sides of a right angle triangle equals the hypotenuse squared. So the sum of the two shorter sides, the square of the two shorter sides equals the square of the hypotenuse. So x squared a squared plus b squared equals c squared. So a squared is 1 squared plus 1 squared equals ac squared, and that's what we want to find. 1 plus 1 is 2 equals ac squared. I just want to find ac. So AC is going to be, got to square root both sides to get rid of that square. It's equal root 2. Okay, and you can put it in your calculator if you wanted to get a decimal. 1 point, it'll be approximately 1.41. So AC is approximately, but for this case, I'm going to leave it as root 2. Just I want to use the exact values because I don't want to round too early. So when I start rounding early, my final answer becomes really distant from the real one. So now I know that AC is root 2. That's this section here. Okay. So now for the second the red triangle, I've got this length here, which is root 2 or 1.41, and I've got 1 meter here. So I can use this triangle to find AB. Okay, so once again, AB squared equals, so the same, C squared, I just switched the formula around, the sum of the squares of the two shorter sides. So 1 squared plus AC squared. So AC, I'm going to leave it as root 2. You can use 1.41 if you'd like. There's a reason I left it as this. Okay, so 1 squared is 1, and then the square cancels out the square root. Right, so if you do root 2 here and you square it, you get back to 2, because squaring and square rooting are opposite operations, so they cancel. So 1 plus 2, which equals to 3. So AB squared equals to 3. So if I square root both sides to get rid of the square, I'll get AB, because this cancels out that. So AB equals root 3, which is approximately 1.73. So use a 1.73 meters. Okay, so once again, I did not specify whether to leave it in exact form or in 2 decimal places, but I've given both anyway. So write meters up here. Alright, so hopefully you guys found that video useful. I do apologize once again if I sound tired, but we managed to do some maths and finish at 3 AM, so perfect timing. So yeah, let me know if you still have any questions on Google Classroom after watching this video, and I should be able to get back to you as soon as I can. Have a good one, you right?